Welcome to Unit 9. We look at the product rule. First of all, something about functions, how we build functions. More functions. We have already seen basic functions like sin x. We have seen e to the x. We have seen log x. So we can add them up, we can also multiply them, and we can build functions like this. And we know how to differentiate them, and also we know what happens when we multiply with a constant. Right? If you multiply this with a constant, this is the derivative of this is just, we know how to do that, so this is 3 cosine x plus e to the x, and then plus 1 over x. So we know how to differentiate sums, we know how to differentiate these, we know how to differentiate basic functions. But we don't know how to differentiate, how do we differentiate say sinus x times e to the x? Or how do we differentiate d over dx sinus of exponential function? So if we combine a function with the exponent, what happens when we multiply? What happens if we differentiate 1 over sine x, the cosecant? How do we differentiate that? So, or how do we differentiate tangent x, sinus x over cosine x? So these are problems for which we need rules. Now this we discuss next time. We discuss that on Friday. This is the chain rule. And these cases we will discuss today. This is the product rule, the reciprocal rule, and the quotient rule. Will deal with this. The product rule is due to Leibniz. Let me show you how Leibniz thought about this. So if we have two quantities f and g, we can think of them as the product as an area. So when we multiply them, that's f times g. Now if we change f and if we change g, so this both changes the area. But what we are interested is in the total change of the area. We are interested in, so this is f, this is df, and this is dg. And when we are looking at the change, you kind of can see that df, just write it down like that, dfg, the change of fg, is equal to f times the change of dg. Let me just write f plus df times dg plus, and then we have another part which is g times df. So this is an exact identity. I will write you down the identity again just in a second. So what we have is, this is f plus df times dg, that's this part here. And then we have another part here which is g times df. So let me write you down that again. So what we actually have an exact identity. What it actually means is, so that has cancelled away. This part, this times this is equal to that times that. That's with the negative sign, that's with the positive sign. That goes away. So fx plus hg, x plus h is here, and fx gx is here. So if we take that identity and we divide this identity divided by h, so we take this divided by h, take this here, divide by h, and this divided by h, you see that goes to the derivative of fg, and that goes, so that's what we have here, and goes to the derivative of fg prime, that's what we have here. And that goes to the derivative of, that goes to g times f prime. So it's absolutely fantastic. This is the quantum version, true, you know, precisely for every positive h, for every function, not only for smooth functions, for every function this holds here. And now when h goes to 0, then we need the derivatives to exist. But then we have this rule. Okay, here are two examples, and we can do that right away. So what we have, this is cosine x e to the x plus sinus x e to the x. Here, if we take that, so that's 5x to the 4 log x plus x to the 5 over x. Okay, so the second rule is the reciprocal rule, which we can immediately get from the product rule. Because what we have is we have f times 1 over f. And then we have f divided by f, of course we get just 1. And now we can differentiate that. So we get the derivative of this, of 1. Of course that's equal to 0. And now we can use the product rule. Product rule tells us that's f prime times 1 over f plus f times 1 over f prime, which we don't know, that's equal to 0, and that's what we don't know. We can now put on one side. 1 over f prime is minus f prime over f, and then we have to divide by f. So we get divided by f squared. Okay, here's an example. The secant is 1 over cosine, so that's d over dx, 1 over cosine x. Now we know from the reciprocal rule, we take the derivative of cosine, it's minus sinus x. But then we have also a minus sign there, so that becomes plus, and then we have cosine square x. So that's actually nothing else than tangent x times secant x. So secant's derivative is tangent x times secant x. So that's one of the things. Here also, that's just directly we take the derivative of log x, which is minus we have a minus sign here, always don't forget that, minus 1 over x, and then we divide by log x squared. So we can write this as minus 1 over x times log x squared. Okay, the quotient rule immediately follows from the reciprocal rule, because what we have is if f times f divided by g, we can just write as d over dx fx times 1 over g. And now we have the product rule. By the product rule, this is f prime 1 over g plus f times 1 over g prime. So that's what we have used. We have to use the product rule. And now we can use the reciprocal rule for this one. So this is f prime 1 over g, and then minus f g prime over g squared. So this is the reciprocal rule. And we can simplify that a little bit. So we can write it as, actually I want to write it as equal to g, if we take g on the other side, f prime, we take a common denominator, minus this is the quotient rule. Low d high, take high d low, cross the line and square the low. Just one example, we want to take the derivative of the tangent x. So what we have is, let me just take the derivative of tangent x, write it as d over dx sinus x over cosine x. So this is the low and this is the high. So we have the rule, low d high, low d high, take high d low, cross the line and square the low. So you see this is actually cosine square x minus plus sine square x, cosine square x plus sine square x over cosine square x. So that's 1 over cosine square x. So this is the secant square x. That's kind of a pretty cool thing to know.